Hi guys, now let's do the last one now. Last one of the week. Hopefully you're happy. I know you're doing a lot this week to complete quadratic, but work hard. Not many things to do anyway at home. Should be fine. But yes, well, I'll try to give you a bit less next week. Okay. The last section, the topic is simultaneous equation. Previously, we deal with linear and linear, wasn't it? So let's think about that. Linear and linear, two lines there, same gradient, different y-intercept, they never meet, no solution. Do you remember that? Yeah? I'll just write down here. Linear and linear, which one is no solutions, wasn't it? Another one was same gradient, same y-intercept. So this was identical, like the same graph. Yeah. And the last one, the possibility was they meet one point. Okay. And let's say y equals 2x plus 1, y equals minus 3x plus 2. They meet together only at this point, and that x and y value gonna be the same only at this point. Okay. To solve this, what did we do? Y equals, at that point, the y value and x value are the same, so y is same as that y, which means the y is 2x plus 1, y is minus 3x 2. Therefore, 2x plus 1 and minus 3x plus 2 has to be the same. 2x plus 1 equals minus 3x plus 2. And when we solve it, we'll get x. And then put that x into that equation, we can get y. So we get x and y. That's what we did from linear equation, isn't it? So I'm not going to go through the whole thing, but I explained it. So we're doing exactly the same thing here. Exactly the same thing, but we actually wrote discriminant. So we can actually see when did we use discriminant? How many values there, wasn't it? Like this, when discriminant is bigger than 0, you have two solutions. Previously, when discriminant b squared minus 4ac equals 0, you have one solution. Less than 0, no solution, wasn't it? So same thing happened here, same thing. You can use that discriminant in this case as well for simultaneous equation. So in this case, we're dealing with one linear and one quadratic function. So we'll have quadratic and linear. Okay? So there are three possibilities we can have. One is that do they meet any points? No. I mean, it could be like this too. Do they meet any points? No. So there is no solution situation. That happens when discriminant b squared minus 4ac is less than 0. Okay? Then we're not going to have any solution. There is no points have the same value. Next one, we actually hit something like this or anything like that. Yeah. We have one point, these two lines, one is linear, one is quadratic, have same value. Only one point. That's why we said there is one solution. Good. And also discriminant equals 0. b squared minus 4ac gonna be 0. Okay. And last one, they could just pass through, isn't it? the 1 and 2 point. They're going to be 2 points. These linear and quadratic functions have same values, 2 points. So also I can say they meet in 2 points. So we can use discriminant, okay, to find how many values we could have between linear and quadratic. That sounds okay? Okay. If you understand, we move on to the examples. You should be able to do it easily. Oh, I'll scroll down here a bit. I'll just do that here. Prove that straight line, okay, we have y equals 1 minus x straight line, parabola, y equals x squared minus 3x plus 2. And they said meets only once, which means discriminant b squared minus 4ac equals what? 0. So how do we get that? Okay, let's start. We will have something like this. The one point, these two graphs will meet together. Well, that's what they say, isn't it? Meet only once. Yeah? Which means at that point, they're going to have same x and y value, which means y equals y is 1 minus x, y is x squared minus 3x plus 2. Therefore, they are the same too. Always same, always simultaneous equation. 1 minus x equals x squared minus 3x plus 2. That's the first thing you need to do. And then you rearrange that, make equals 0. Okay? So x squared, move here, minus 2x, move plus 1. Get that? Yep. And we use that, this quadratic equation, to get discriminant. So in this case, a is 1, b is minus 2, c is 1, isn't it? Yeah. So discriminant equals b squared 4 minus 4ac. Therefore, 4 minus 4 equals 0. So discriminant is 0. Which means what? They meet only once. I proved that. Does it make sense? Okay. I will just do extra thing here. So I actually finished the question, but I'll continue from that. X squared minus 2x plus 1 equals 0, wasn't it? Which means you can factorize it. 1 equals 1, but when we add it, we have to make minus 2. I can put minus and minus, isn't it? So x 0 equals x minus 1, x minus 1, x minus 1 squared. Therefore, when we make that 0, x minus 1 equals 0, x equals 1. Isn't it? When x equals 1. And then you go back to original question, plugged in 1 square, y equals 1 square minus 2, 1 plus 1, 1 minus 2 plus 1, 0. So y equals 0. So when x is 1 and y is 0, that's the point when they meet. So this point, which is 1 and 0, these two lines, one's linear, one's quadratic, meet at this point. Do you understand? Yeah. So let's just go back and think about it. If the question asks you how many answers, how many points they meet, how many solutions they have, you put the linear and quadratic the same, you get A, B, C, and then getting determinant and check, are they bigger than 0? If they're bigger than 0, you got two solutions equal to 0, one solution smaller than 0, no solution exists. Okay? And then If you want to get at that point, since we know determinant is 0, we have one solution. I want to get the one solution, which means x and y point, isn't it? That's why I've done that. I factorize it, x, I get x equals 1, and plug back 2 to get y. So I get 1 and 0 out of it. Okay, then let's go to next question. Sketch equation y equals x squared plus x minus 2 and y equals 3x plus 1. Well, let's sketch that first. Okay. Show any points of intersection. So I need to get the intersections. X and y intercepts. Okay. And no turning points. So I don't need turning points. Only intercepts and intersection when they meet. Okay. Let's do linear first. Y equals 3x plus 1. Well, you want to draw linear. Hopefully you remember this. But what do you need? You need 2 points or y-intercept and x-intercept. We'll make 1 point each as well, isn't it? Then we can draw one straight line. In this case, y-intercept is when x equals 0. It's always same. When x equals 0, y equals 3 times 0 plus 1, y equals 1, isn't it? Or, that's y-intercept anyway. Y is 1. Okay. And x-intercept when y equals 0, 0, 3x plus 1, minus 1, 3x, x equals 1 over 3. Minus 1 over 3. And then we'll link the straight line here. That is y equals 3x plus 1. We get that. Okay. And then we're dealing with quadratic, x squared plus x minus 2. We done it. But they don't need turning point. So I don't need to make that to turning point form. All I need to do, getting intercepts. When, let's say y-intercept is when x equals 0. So y equals 0 squared plus 0 minus 2 minus 2. We know that that's y-intercept anyway, but minus 2, negative 2. Okay, so this one, x squared plus x minus 2, a is positive, so it will look like something like that. But I know that will pass either this or that way. Okay, that's the y-intercept. I need x-intercept when y equals 0. When y equals 0, x squared plus x minus 2. Okay, we can factorize it to 1 minus here x and x, because when we add it has to be 2 minus 1, so it works, equals 0. Therefore x equals minus 2 or x equals 1 makes 0. Therefore x-intercept is minus 2 and 1. And we're drawing graph, positive graph here, isn't it? Yeah. So I'll draw that. Rough drawing. Yeah, rough drawing. I'll have two meeting points, isn't it? Two solutions. Well, b squared minus 4ac, when we put they are the same, and then we can actually get discriminant and see how many solutions they have. In this case, the discriminant going to be bigger than 0. Okay? Well, you can do it at home. But in this case, all I need to get intercepts and point of intersection. Okay? In this case, point of intersection is y equals x squared plus x minus 2, y equals 3x plus 1. At that 2 points, we have same x and y solutions, isn't it? Yeah. So these are same as that equation. X squared plus x minus 2 equal to 3x plus 1 is always the same. Move everything to one side. Minus 2x minus 3 equals 0 will make 0. And then factorize it. 3 times 1 is 3, is minus. But when you add it, it's negative, so I put negative the bigger number. X minus 3, x plus 1 equals 0. Therefore, x equals 3 or minus 1. So, x is 3 or minus 1. So, it's negative. Therefore, here is minus 1. Here is 3. That makes sense? Yep. X could be 3 or minus 1. So we separate them. When x is 3, y value is what? You can, going back to any of equation, because we're going to get same value, so it doesn't really matter. We can substitute this in to any of equation. Well, why do we do complex one? Just do simple one. 3 times 3 plus 1 equals 10, isn't it? So when x is 3, y is 10. When x is 3, y is 10. So I can write down 3, 10. And the next one, when x is minus 1, y is 3 minus 1 plus 1 minus 3 plus 1 minus 2. So when x is minus 1, y is minus 2, minus 1 minus 2. Not very correct, and I'll indicate it, minus 1 minus 2. So let's go back and check. Show any point of intersection. I show 2 points. Make sure you indicate it. Yeah. And x and y intercept for linear, done it. Quadratic, done it. So, all good. If they ask turning point, I can actually get turning point from turning point form. Yeah. Or you complete a square. Turning point formula. Does it make sense so far? Okay, we've done that. Hopefully you're able to do this. Let's go to next question. Okay. The graph of equation y equals x squared plus 4x plus 33 and y equals mx plus 24. Okay. So coefficient is m, unknown. Intersect only once, which means these two graphs, one and the line, intersect only once here, once. That means the x squared plus 4x plus 33 equals mx plus 24, isn't it? Yeah. And move everything to one side, plus 4 minus mx plus 33 minus 24, 9. Yeah. Equals 0. Yeah. From there, discriminant b squared minus 4ac has to be what? Intersect only once, 0. Intersect 2 points, meet twice, bigger than 0. No solution, smaller than 0. So now you know that, don't you? Okay, but that's how you use it after this. You know, you put together, are they the same? And then you move everything to one side, and using that. In this case, a equals 1, b equals 4 minus m, c equals 9. Can you do it, please? Can you do that? You pause it and do it first. Okay. I hope you've done that. Discriminant equals b squared minus 4ac. That has to be 0 in this case. b squared minus 4m squared minus 4ac. Isn't it? So 4, 4, 16 minus 8m plus m squared, I expanded, minus 36. Therefore, m squared minus 8m minus 20. That's the discriminant. I solve it. And in this case, intersect only once. Therefore, there has to be 0. So m squared minus 8m minus 20. To get x, factorize it. Yeah, because it's a 0. 5, no, 2, 10, isn't it? 2 times 10, 20. But it's negative, so I have to put negative. It's when we add it, it's minus 8. Therefore, I put negative bigger number. M 0 equals m plus 2, m minus 10. Therefore, m equals minus 2 or 10. Yeah. Did you get that? Yeah. But there is a find the possible value of m, so we've done that. Okay. Or I can just actually put into that equation. So y equals minus 2x plus 24 from here, or y equals 10x plus 24. Let's go and draw and have a look. So when we look at that, so the question actually finished here, but I'll go and have a look. I'll just draw that. Y equals x squared plus 4x plus 33. Okay, then plus 2 squared, isn't it? Turning point form. Yeah. And minus 4 plus 33. X plus 2 to plus 29. Just getting the turning point. Minus 2, 29. That's the turning point, isn't it? And that is positive, therefore it will look like this. And then y equals mx plus 24. Y-intercept is 24 here, 24. And then the case we meet only once is this. Draw that. We meet only once here. Oh, sorry. Can you see that? Yep. Another case. Something like this. And we meet another point. Isn't it? So that red line here will be this. Y equals 10x positive. So it's going up. 10x is really, gradient is very high. And the blue one here is negative graph, isn't it? Going down, minus 2. So that's minus 2x plus 24. That is 10x plus 24. Hopefully you're able to draw that as well as an extra. Okay, we've done that. So I'll wrap up simultaneous equation. So you will have quadratic and linear, and you put two equations are the same, and then move everything to one side. Probably much easier move linear to quadratic, isn't it? And then 0 equals, you got the new quadratic formula there. Okay, if the question asks you how many solutions you have, you use what? Excellent. Yep. Discriminant. B squared minus 4AC bigger than 0, equal to 0, smaller than 0. Okay, we get 2, 1, no solutions. And then I actually draw it, wasn't it? 2 solution, meet twice, 1 solution, meet once, no solution, doesn't meet. Okay. And what else I need to do? We'll make sure you need to able to draw, linear and quadratic. That's what we've done so far. Easiest way is just getting y-intercept and x-intercept. Okay, and then add intersection points. That's all you need to do. And you probably have like given 1 point, then to get another coefficient here. And that's pretty straightforward as well, and I'll show you how to draw that as well. So that's the two possibilities they have. Okay, I know you've done a lot today. I appreciate it, but do your best, and by Friday afternoon, that's my expectation, but I will check on Monday and then give you your attendance through the week. Okay, so if you're not able to do it, you can spend some time to complete by Sunday. Okay, but usual expectation is Friday afternoon. Next class I will start cubic. Okay, thanks guys, have a good weekend. See ya.